Okay guys, we're starting on our second video here. I'm not sure if we got to this problem in class before. The zombie virus got us all secluded from one another. We may have gotten to this. If we did, then you can just fast forward to the next problem. But I wasn't sure, so I thought we'd go back over it. Again, this is very similar to some of the problems that we did in the first video. And the fact that you can't just use your general rule for finding a derivative of an exponential, because we have a variable in the base and a variable in the exponent. Okay, so we have got to get these two guys pulled away, and so we can use logarithmic differentiation to do that. So the first thing I want to do is take the natural log of both sides. Okay, so we have the natural log of y equals the natural log of the cosine of x. That doesn't look good right there. Cosine of x to the power of the cosine of x. And then, of course, I can apply my power rule for logarithms and take this exponent and move it out front as a coefficient. So we get the natural log of y equals cosine of x times the natural log of the cosine of x. Okay, now that I have the base and the exponent separated from each other, I can take the derivative straight across using logarithmic differentiation. So the derivative of the natural log of y, 1 over y, times the derivative of y, which is dy dx, and obviously that's what we're looking for, dy dx. On the right-hand side, again, we've got a product of two functions, so we got to use the product rule. So I go the first times the derivative of the second, so cosine of x times the derivative of the natural log of the cosine of x is 1 over the cosine of x times the derivative of the cosine of x, which is the opposite of the sine of x. Okay, so that is first times the derivative of the second. Okay. All right, then we have to go plus the second times the derivative of the first. So we go the natural log of the cosine of x times the derivative of the first, which would be the opposite of the sine of x. Okay, so it looks like we want to clean things up here. Okay, I'm not going to deal with the y yet. I'm just going to clean up the right-hand side. So, of course, we have cosine times 1 over cosine, so those cancel each other out, so we're just left with the opposite of the sine of x. Okay, then right here it looks like we have minus sine of x times the natural log of the cosine of x. Okay. Let's see. We are going to multiply both sides by y. Okay, so our dy dx equals multiplying both sides by y to get dy dx by itself. Y times the quantity of the opposite of the sine of x minus sine of x times natural log of the cosine of x. Okay, and then of course we know what y is from up in our original function, so we can go ahead and substitute that in there. Okay, and then I'm also looking here, what can I do with this? So we have cosine of x to the power of cosine of x times the quantity of negative sine of x minus sine of x times natural log of cosine of x. And I would say that is certainly one form of your answer. I don't think there's anything wrong with that. It's a little busy looking, but it is correct. I'd say about the only thing we could do here that I'm looking at it is how about we factor out the opposite of the sine of x from both of these terms and put it out front. So we could say, different form, the opposite of the sine of x times cosine of x to the power of cosine of x times the quantity of Well, I factored out a negative sign, so remember these signs will change here. Okay, so that would be 1 plus natural log of the cosine of x. And that would be another form of the answer. Okay, and then don't forget that's a negative sign out here. Okay, I don't see anything else to do with it, so that should be okay there. Let's go on to the next guy. Okay, this guy right here is a little bit different than the problems we've been doing. Kind of a cool problem, I'll be honest with you. So obviously we have a function there, and it's an exponential. So we know we're going to have a curve, and it wants to know at what point. Okay, and this is really important, at what point. Okay, so that means we need an x-coordinate and a y-coordinate because it's asking about what point, okay, will the slope of the tangent line be equal to 16? Well, going way back towards the beginning of the year, we know that when we first started talking about derivatives, the derivative is a function that gives us the slope of a tangent line to a point on a graph. So to be able to do this, we have to take the derivative of y, okay, and that gives us our slope function, and then we set that equal to 16. And then we solve for x, and when we get x, that'll be our x-coordinate, and once we have our x-coordinate, we can put that right back in here and solve for our y-coordinate. Okay, so let's see, we've got to do dy dx. Okay, so the slope that we're looking for, okay, will be dy dx. So when we do that, notice this guy's just straightforward, so we can go right back to our rule for finding the derivative of an exponential. So it's going to be the exponential 4 to the x times the natural log of the base, so that'd be natural log of 4, times the derivative of the exponent, which would be 1, and then obviously when we take the derivative of 7, we get 0. So our dy dx is just 4 to the x power times the natural log of 4. So we want to know when will this function, okay, our derivative, which represents our slope function, or slope of a tangent line function, I should say. So when will this be equal to 16? So we have to take this guy, set it equal to 16, and then solve. So we have 4 to the x power times the natural log of 4 equals 16. And we've got to figure out, okay, when's that going to happen? Okay, so we have to solve for x, obviously. So that means we're going to have to get rid of this natural log of 4. That's just a number. Remember, that's just a constant multiplier. So just divide both sides by the natural log of 4. So we get 4 to the x power equals 16 divided by the natural log of 4. All right, now, the x that we're solving for is in the exponent, which makes it tougher, obviously. We've got to remove it from the exponent. Okay, and if we can remove it from the exponent, then I can isolate it. So since it's in the exponent, why not take the natural log of both sides? Okay, and when we do that, on the left-hand side, notice that I will be able to apply my power rule for logarithms and move that guy out front as a coefficient. Okay, so be careful with everything. Natural log of this whole thing. So 16 divided by the natural log of 4. Okay, and then I can take this guy and move it out front like that. Okay, so I get x times the natural log of 4 equals the natural log of this whole thing. 16 divided by the natural log of 4. Okay, and then notice I have to divide by the natural log of 4 to get x by itself. So I get the natural log of 16 divided by the natural log of 4, all divided by the natural log of 4. Okay, now you can punch that entire thing into your calculator, and if you use your grouping symbols correctly, it'll give you the right answer. I would say the only thing you could do to make it maybe a little bit easier is notice up in the numerator, we have the natural log of a quotient. Okay, so we could apply the quotient rule. So remember, the quotient rule would allow us to take the natural log of a quotient and move backwards. That would be the natural log of the numerator minus the natural log of the denominator. So if I wanted to, I could do this. I'd have the natural log of 16 minus the natural log of 4, all divided by the natural log of 4. Now, I want you guys to understand, you could punch it in this way, and as long as you're punching things into your calculator correctly, using your grouping symbols correctly, it'll work. Okay, so it doesn't matter which way you decide to do it. Okay, I actually punched this guy in already, okay, and got an answer for it. So when you do this, you should get, rounding off the nearest hundredth, roughly about 1.76. And it doesn't matter which way you do it, you're going to get the exact same answer. Okay, so we know up here, okay, our x-coordinate is 1.76. Okay, so I've got to take that guy and I've got to find my y-coordinate. Okay, so my y-coordinate, okay, I just go back to my original function. And we get y equals 4 to the power of 1.76 plus 7. And you just go into your calculator and punch that in. You use your little caret there. Okay, I did it already. I'll do it again just to make sure I got it right. Okay, so 4, my little caret, 1.76, hit enter, and then add 7. And we get 18.47, which I got the first time. 18.47. Okay, so that would be our y-coordinate, 18.47. Okay. That's the second video of the week. There will be at least one more to come. And you guys make sure you stay safe out there. Stay away from other people. Stay inside. Okay, stay away from the zombie virus. See you soon.